Okay, now we're getting into some log functions that are a little bit tougher. The first few were sort of gimmies, I think, but I wanted to remind everybody where we're at, and that includes myself. And you know what's going to be the real sticker for this one? Is that we need to remember algebra to make this easy. Because before I take the derivative of this function, I want to remember some rules, otherwise it's going to be a nightmare. We've got exponents, we've got square roots, so we got logs in here. This could be scary. But I want to remind you some things that are going to make this easier. I'm looking at them in my head already, so I just want to write them out. The first one is that if I have a natural log of a u divided by v, I can rewrite that as a natural log of u minus the natural log of v. And that's going to come in handy here. I do not want to do a quotient rule. F that. No thank you. I'm just saying, as we go. And another one is if I have the ln of a u to the v, I can rewrite that by bringing this out and do v ln u. That's nice because we have an exponent in this one. And then, of course, one you should probably know already is the square root of u can also be rewritten as u to the 1/2, because I prefer using a power rule than anything else. It's the easiest. So let's rewrite this function just with algebra before we do anything else, right? I'll draw a little line here. No, it's not necessary. If you can't figure that out, you don't belong in calculus. So let's first write this as ln of 2y plus 1 to the 5th minus ln of the square root of y squared plus 1. And then let's do the power rule function here, or just the algebra power rule function for natural logs, I guess we call it. And we'll make it 5 ln of 2y plus 1. I guess no parentheses needed there. Minus, and that square root counts as an exponent as well, 1/2 ln of y squared plus 1. Now this is far less daunting. I think I'd be willing to take the derivative of these. Not nearly as scary. And just because it says y, remember y is not a function of x here. So we're not going to do dy dx. You can think of this as just like having a regular x. See how this says function of y? So this is like not the same as doing dy dx stuff. That is a trick. Do not fall for that trick. Remember how x and y work. X is an input, y is a function of that input, usually. But here they're just using y as a variable. Just to make sure that you understand it, they're messing with you. So let's take the derivative of this whole thing. And you know, we can bring the 5 right out. In fact, let's just come down a little here. Let's bring the 5 out. And then the derivative of natural log is 1 divided by, well, it says 1 over x. That's not what it is, right? It's 1 over the input. So that's that. And then chain rule times the derivative of the inside. Well, what's the derivative of the inside? 2. So we'll come to that in a minute. And we'll do the derivative on this side. We've got a 1/2. And then it's going to be times a 1 over the input, y squared plus 1. Times the derivative of the input again. That's going to be 2y. So you see no dy dx is here. Okay, so what does that give us so far? That gives us 10 on this side over 2y plus 1 minus 2. Well, I guess this 2 and this 2 cancel, don't they? So maybe we'll just take the 2 away and we'll do it y over y squared plus 1, like that. This is about as simple an answer as you can get. And it's the correct answer, which is a plus.